In this lesson, we'll examine a very useful strategy to consider when answering quantitative comparison questions. The technique is to perform the same operations on both quantities. In particular, you can add any value to both quantities, subtract any value from both quantities, multiply both quantities by a positive value, and divide both quantities by a positive value. Now, this is a very common technique that can be applied to a wide range of questions. So let's look at some examples. In this question, notice that both quantities share some identical terms. They both share a positive y term, and they both share a negative 3x squared term. We can eliminate those terms by performing the same operations on both quantities. To begin, let's add 3x squared to both quantities. When we add 3x squared to quantity A, it cancels out the negative 3x squared term, and it cancels out the negative 3x squared term in quantity B as well. From here, if we subtract y from both quantities, we're left with negative 7 in quantity A, and we're left with 6 in quantity B. At this point, when we compare negative 7 and 6, we see that 6 is greater, which means the correct answer is B. Now, I should point out that if any of the algebra here confuses you, do not worry. We'll cover all of the necessary algebraic concepts in a future module. At the moment, just familiarize yourself with the technique of performing the same operation on both quantities. All right, let's try another one. Now, you may wish to pause the video and try this one before continuing. Okay, in this question, it would be much easier to compare the quantities if the variables were on one side and the non-variables were on the other side. To accomplish this, let's first subtract w from both quantities to get the following. Next, we'll subtract 4 from both quantities to get this. At this point, the variable is on one side and the constant term is on the other side. From here, we can simplify matters even further by dividing both quantities by 6 to get the following. At this point, it's very easy to compare the two quantities. Since the given information tells us that w is greater than 0, we know that w is positive. As such, w must be greater than negative 1, which means the correct answer here is A. As you can see, we were able to solve this question by performing a combination of these acceptable operations on both quantities. Now, when it comes to acceptable operations, you may be wondering why we can't divide or multiply both quantities by a negative value. To answer this question, let's examine a very rudimentary question. Now, of course, it's obvious here that quantity B is greater than quantity A. However, notice what happens when we perform any of the acceptable operations on each quantity. For example, if we add 8 to both quantities, we get these results. And as you can see, quantity B is still greater than quantity A. From here, if we subtract 4 from both quantities, the new values are such that quantity B is still greater than quantity A. If we divide both quantities by positive 3, we get these results, and it's still the case that quantity B is greater than quantity A. If we multiply both quantities by a positive 6, the resulting values are such that quantity B is still greater. However, notice what happens if we take our current quantities and divide both of them by a negative value. When we divide both quantities by negative 2, we get negative 6 and negative 9. And now it's the case that quantity A is greater than quantity B. This, of course, is a problem. Our original goal was to compare these two quantities, and when we performed any of these acceptable operations on the quantities, the resulting values were consistent with the conclusion that quantity B is greater than quantity A. However, when we divided both quantities by a negative value, quantity B was no longer greater than quantity A. This problem will occur whenever we divide or multiply both quantities by a negative value. So when it comes to performing operations on both quantities, we must ensure that we only multiply or divide the quantities by positive values. This is a very important rule that often comes into play when we have questions like this involving variables. Since both quantities feature the variable x, it may be tempting to divide both sides by x to get the following, and then conclude that since quantity B is greater than quantity A, the correct answer is B. This, however, is incorrect. The problem here is that when we divide both quantities by x, we cannot be certain that we're dividing by a positive value. If it turns out that we're dividing both sides by a negative value, the results will not be consistent with the original comparison. For this reason, we must not multiply or divide quantities by a variable unless we're absolutely certain that the variable has a positive value only. To demonstrate this, let's look at some possible values of x. For example, what does our comparison look like if x equals positive 4? Well, in this case, quantity A equals 8 and quantity B equals 12, which means quantity B is greater. Now consider what happens if x equals negative 1. In this case, quantity A equals negative 2 and quantity B equals negative 3, which means quantity A is greater. So in one case, quantity B is greater, and in the other case, quantity A is greater. As such, the correct answer here is D. The relationship cannot be determined. Alright, so if we're not allowed to divide both quantities by x here, how can we solve this question? Well, the quickest way is to subtract 2x from both quantities, and when we do so, we get the following. At this point, we're comparing x with 0. Well, since x could be less than 0, or greater than 0, or even equal to 0, the answer here must be D. Alright, let's summarize. In this lesson, we learned that we can simplify quantitative comparison questions by performing the same operations on both quantities. We also learned that we must not multiply or divide the quantities by a variable unless we're absolutely certain that the variable has a positive value only. In this video, we'll examine a strategy to consider when dealing with quantitative comparison questions that involve variables. To set this up, consider the following question. Now, one possible way to solve this question is to use the strategy we examined in the last lesson and perform certain operations on both quantities. So we might begin by subtracting 4x from both quantities to get this. Then we can subtract 4 from both quantities to get this. And finally divide both sides by 2 to get this. At this point, we're comparing x with 1. And since x can be less than 1, greater than 1, or equal to 1, it's clear that the answer here is D. Alright, now let's examine a different approach. For this approach, let's plug in different values for x and see what happens. Now keep in mind that when we're comparing quantities involving variables, we're trying to determine whether the relationship between the two quantities remains the same for all possible values of the variables. So for example, in order for the correct answer to this question to be A, it must be the case that quantity A is greater than quantity B for every possible value of x. Similarly, in order for the answer to be C, it must be the case that quantity A is equal to quantity B for every possible value of x, and so on. Now when we plug in values for a variable, we want to use a nice cross-section of numbers, and we want to use numbers that make it easy to evaluate each quantity. A nice set of numbers to choose from are 0, 1, negative 1, 1/2, negative 1/2, 10, and negative 10, since they represent a nice cross-section of all numbers. Let's begin with 0. If x equals 0, then we'll plug 0 into the two quantities and then evaluate to get the following. Since quantity B is greater than quantity A here, we know that the correct answer must be either B, quantity B is always greater, or D, the relationship cannot be determined. This is a great feature of the plugging in numbers approach. After very little work, we can quickly whittle the number of possible answer choices down to just 2. At this point, we'll try another value of x. Let's try x equals 10. If x equals 10, we'll plug 10 into the two quantities and then evaluate to get the following. So when x equals 10, quantity A is greater than quantity B. So in the first case, quantity B was greater, and in the second case, quantity A was greater. Given these contradictory results, the correct answer here must be D. We cannot definitively say which quantity is greater. Now, it's important to note that the main drawback of the plug-in numbers approach is that unless we get two contradictory results, as we did here, then we can never be absolutely certain of the correct answer. Here's what I mean. Let's say that we didn't plug in 10 for x. Instead, let's say that we plugged in 1/2. If x equals 1/2, then the two quantities evaluate to be 7 and 8, in which case quantity B is still greater than quantity A. What if we try plugging in -1? If x equals -1, then the two quantities evaluate to be -2 and 2, in which case quantity B is still greater than quantity A. At this point, we might incorrectly conclude that quantity B will always be greater than quantity A for all values of x. So let's try another value of x. What about x equals -10? In this case, the two quantities evaluate to be -56 and -34, in which case quantity B is still greater than quantity A. At this point, we might be tempted to say that the answer is B, since it appears that quantity B will always be greater than quantity A for all values of x. Now, of course, if we plug in a value like 10, we can see that the answer is not B. If x equals 10, the two quantities evaluate to be 64 and 46, in which case quantity A is greater than quantity B, and given these contradictory results, we can now be certain that the correct answer must be D. So when it comes to plugging in numbers for the variables, the drawback is, if the strategy does not yield two contradictory results, then you can never be 100% certain of the correct answer. On the other hand, this strategy allows you to quickly narrow the answer choices down to two options by plugging in only one value. As such, this strategy provides you with a great approach to handling questions when you don't know how to proceed. For example, consider this question. This is a very tough question, and most students won't even know where to begin. However, since there's a variable in one of the quantities, we might consider plugging in some values. Let's begin with 0. If x equals 0, we'll replace x with 0 and evaluate to get the following. Since quantity A is greater than quantity B, we can automatically take the four possible answer choices and reduce them to 2. The correct answer here must be either A or D. So in a matter of seconds, we can give ourselves a 50-50 chance of guessing the correct answer. Let's try another value. How about 1? Well, if x equals 1, then we'll replace x with 1 and evaluate to get the following. Once again, quantity A is greater than quantity B, so perhaps the answer is A. Now from here, you might wish to plug in additional values of x, or if you're running low on time, you might just guess A or D and move on to the next question. Now if you decide to plug in more values and you get contradictory results, then you can be certain that the answer is D. Conversely, if each result keeps showing that quantity A is greater, then it's quite possible that A is the correct answer. At this point, the choice is up to you, depending on the time you have remaining in the test. Now, before I end this lesson, let's see if we can solve this question in a more definitive manner. Let's begin by subtracting 3 from both quantities. When we do so, we get the following. Now, why did I do this? Well, notice that we can now take quantity A and factor it as follows. Now, as an aside, if any of this looks unfamiliar to you, don't worry. We'll cover factoring in a future module. Now from here, we can rewrite quantity A as x minus 5 all squared. Since the square of any value is always greater than or equal to 0, we know that quantity A must be greater than -1, which means the correct answer here is A. Okay, let's summarize. In this lesson, we learned that if there are variables in a quantitative comparison question, we might consider plugging in values. We learned the main drawback of this approach and the main benefit. And finally, we learned that if you do plug in values, be sure to use a nice cross-section of numbers.